Hey folks, our next unit to talk about starts to get us into some interesting things that are new for chemistry, which are chemical formulas and chemical naming. So in order for us to be able to communicate in chemistry, a great way for us to do it is with formulas, because there's so many elements and so many ways that we can combine them. So 2 units ago, we learned that substances that are pure substances, come in two forms: elements and compounds. Now, when you have pure substances, a way of looking at sort of the whole picture of pure substances is how it's broken down into these elements, into these compounds. So if you look at elements can actually come in two varieties, two types. And one type is an atomic element, and I'll define that in a minute. And the other type is a molecular element. So let's look at that side of this chart first. So examples of atomic elements are elements that are individual atoms, like carbon, carbon and sodium and iron and sulfur here I put. So that's pretty straightforward. But a different kind of element, another form that elements can exist in, is what are called molecular elements. Now, there are actually 7 elements that exist in this way. And for reasons we'll talk about later in the course, they can't exist by themselves. So they exist with another one just like it, and they make a pair. So H2 does it, oxygen, O2, N2, Cl2, Br2, I2, and F2. And these 7 can be remembered by this funky, funny acronym that helps you remember them. And it's HONCLBRIF, which I pronounce Hunkelbrief, which is just kind of a funny way of saying it. There's a couple other different ways of saying it, but Hunkelbrief is a way of remembering what these 7 elements are. Now, those are pure substances that are elements. The other way that substances that are pure can be can exist are compounds. And there's 2 kinds of compounds, 2 ways that compounds can be. One is what are called molecular compounds, and the other ones are what are called ionic compounds. And I'm going to break down what those 2 are right now. So a molecular compound is simply made of 2 or more nonmetals that are combined in some way. And here are some examples. H2O, there's H and O. They're both nonmetals. CO2, CO, both nonmetals. And you can get more complicated, like C2H5OH, more atoms. They're all nonmetals, and so that's a molecular compound. The other type is an ionic compound. Ionic compounds are made of ions. If you remember from the previous unit, that's an atom with a charge. So ionic compounds are made up of 1 or more positive ions and 1 or more negative ions coming together. And they come together because they attract. If you remember, opposites attract, right? And you end up with an ionic compound. So, summing it up, pure substances can exist as either elements and compounds. Elements can be either by themselves, atomic, or they could be molecular pairs. Compounds, which are also pure substances, can be molecular or ionic. Molecular, nonmetals with nonmetals, and ionic compounds are ions that are attracted to each other that have opposite charge. Now, when we represent these compounds, we need to show what's in them. So what we do is we represent them with the elements that make up the compound and then the number that you have of each. And this is the general way that it's done. You have the chemical symbol, and that identifies what it is, and then a subscript indicating how many there are of that individual element. So here, H2O. 2 is a subscript for the H that tells you there's 2 of them. O, there's no subscript that you see. It's an understood 1. So that means there's 1 of those atoms. So H2O is how we would show it. So an element symbol and a subscript right after it.